SCD Type 2 fact joins are the daily reality of every analytics and data engineer working with data warehouses. Interviewers use this pattern to test whether candidates understand temporal data modeling, non-equi join mechanics, and the real-world consequences of join multiplication in production pipelines. Your revenue dashboard just tripled overnight. Nobody celebrated because the data is wrong. A single update to your customer dimension table just multiplied every order across 3 historical versions. This is the SCD Type 2 join multiplication bug, and it is the most common data warehouse integrity failure in production. Let me show you exactly how it happens and how one surgical fix eliminates it completely. Here is the trap most candidates fall into. They write a standard equi-join matching only on customer ID. Watch what happens. Order 1001 from Alice in February doesn't just match her bronze record. It matches silver. It matches gold. Every single order fans out across every historical version. 4 orders become 10 rows. Revenue jumps from 1630 to 4090. The numbers are completely wrong, and the query ran without a single error. Let's trace exactly why this breaks. Customer 101, Alice, has 3 dimension records. Customer 202, Bob, has 2. When you join only on customer ID, the database does exactly what you asked. It matches every fact row to every dimension row that shares the key. Alice's 2 orders each produce 3 matches. Bob's 2 orders each produce 2. That's 3 plus 3 plus 2 plus 2 equals 10 rows. The optimizer executed your query perfectly. The logic was wrong. This is an O of n times V explosion, where V is the average number of versions per business key. The fix is exactly 2 additional predicates. After matching on customer ID, add a lower bound. The order date must be greater than or equal to the effective date. Then add an upper bound. The order date must be strictly less than the expiry date. This is a half-open interval, inclusive start, exclusive end. Now each fact row lands in exactly 1 dimension window. Order 1001 from February matches only bronze. Order 1002 from May matches only silver. 4 orders, 4 rows, 1630 in revenue. The data is correct. 2 edge cases will trip you in production. First, late arriving facts. An order arrives before any dimension record exists for that customer. With an inner join, that order silently disappears. Switch to a left join and use coalesce to assign placeholder values. Second, the current active record often stores null in the expiry date column instead of a far future sentinel. Your range condition breaks on null comparison. Wrap it. Coalesce expiry date to 9999-1231. These 2 guards make your join production safe. Lock this mental model permanently. Every SCD Type 2 join needs exactly 3 conditions. 1, the business key match. 2, the lower date bound, greater than or equal to effective date. 3, the upper date bound, strictly less than expiry date. Miss either bound and your facts multiply across history. Add coalesce for null expiry dates and left join for late arrivals. 3 conditions, 1 match, correct data. That is the pattern that survives production. Let's analyze the key-only equi-join, the trap approach. Time complexity, O(n*(v). Space complexity, O(n*(v). Each fact row fans out across V historical versions per business key, producing N*(v) result rows and inflated aggregates. Let's analyze the non-equi range join optimal approach. Time complexity, O(n log m). Space complexity, O of n). Range predicates on effective/expiry dates let the optimizer seek to exactly 1 matching dimension version per fact row. Let's analyze the surrogate key premap ETL pattern approach. Time complexity, O of n. Space complexity, O of n. Premapping surrogate keys during ETL eliminates the range join at query time, but requires upstream pipeline support. The interviewer will then ask, What happens if a fact record arrives before any dimension version exists for that customer? This is a late arriving fact. With an inner join, it silently drops the row, losing revenue data. The fix is to use a left join and coalesce null attributes to placeholder values like unknown, then reprocess when the dimension record lands. The interviewer will then ask, how would you optimize this join if the dimension table has millions of historical versions? Pre-map surrogate dimension keys during the ETL load phase, so fact rows carry a direct foreign key. At query time, this converts the range-bound non-equi join into a simple equi-join on the surrogate key, reducing complexity from O(n) log m to O of n.